Right now, a lot of people in the United States are focused on the flashy side of AI. They're talking about apps, video generation, and the latest consumer tools. Today, one of the clearest signals of that is the surge in US search interest around Sora on Google Trends. But while the internet is watching the surface of AI, a much bigger story is unfolding behind the scenes, and it's happening in the Middle East. Because the real power of AI is not just in the app you open on your phone, it is in the compute, the cooling, the chips, the electricity, and the engineers trying to keep massive AI systems online every second of the day. And right now, the Middle East is becoming one of the most important battlegrounds in that race. So what is happening inside AI data centers in the Middle East? Why are governments, big tech companies, and chip suppliers suddenly treating the region like a strategic AI corridor? And why is all of this creating intense pressure on AI engineers, infrastructure teams, and operations specialists? That is the real story today. The latest update starts in the UAE, where OpenAI announced Stargate UAE, calling it the first international deployment of Stargate, its AI infrastructure platform. According to OpenAI, the project includes a 1 gigawatt cluster in Abu Dhabi, with 200 megawatts expected to go live in 2026. OpenAI says the partnership involves G42, Oracle, NVIDIA, Cisco, and SoftBank, and is part of a broader framework tied to the US-UAE AI relationship. And that is not a small detail. 1 gigawatt is not a normal data center conversation. That is the kind of scale that tells you this is not about building a few server rooms for local cloud demand. This is about building a regional AI backbone, a compute platform meant to serve a much larger geography. OpenAI said Stargate UAE could potentially provide compute capacity within a 2,000-mile radius, reaching up to half the world's population. That is a huge strategic statement because it means the Middle East is no longer trying to be a side market in AI. It is trying to become infrastructure. And the UAE story gets even bigger. G42 said a broader UAE-US AI campus was unveiled at 5 gigawatts, describing it as the largest AI infrastructure project outside the United States. That matters because it shows the region is no longer pitching isolated tech zones. It is pitching a full-scale AI corridor built with American partners, American chips, American cloud relationships, and security controls designed to reassure Washington. Then came another major development. G42 said it received U.S. approval for advanced AI chip exports, allowing the move from planning to deployment. In plain English, that means one of the biggest bottlenecks in AI infrastructure, access to advanced semiconductors, is starting to open up for these projects under a regulated framework. G42 said this approval supports foundational efforts already underway, including Stargate UAE, and described deployment under a compliance structure aligned with U.S. export and security rules. Now think about what that means operationally. The moment you go from announced project to approved chips to deployment, the pressure shifts instantly onto engineers. Because slides are easy, renderings are easy, ceremonies are easy. But once advanced chips are approved and delivery becomes real, the hard part begins. Engineers now have to answer the questions nobody on stage wants to answer. Where does the power come from? How do you cool dense GPU clusters in desert conditions? How do you protect uptime? How do you handle compliance? How do you build a facility secure enough for strategic AI workloads and fast enough to satisfy political timelines? That is where the stress lives, and the UAE is not stopping there. Kazna, one of the most important data center operators in the region, announced a collaboration with NVIDIA to accelerate AI infrastructure development across the Middle East and Africa. Kazna said NVIDIA had certified the design of its next-generation facilities for Blackwell architecture, and that the company plans to design most future data halls at up to 50 megawatts each, with individual AI clusters of up to 250 megawatts. Kazna also says its current portfolio stands at 673 megawatts, with 30 live data centers and multiple projects underway. For a US audience, here is why this is a big deal. The conversation is no longer just, can the Middle East host cloud workloads? The conversation is now, can the Middle East run frontier AI at hyperscale? Those are two very different questions. Traditional cloud growth is one thing. AI factories are another. They require different power densities, different thermal management, different network designs, and much tighter operational tolerances. When the racks get hotter, the workloads get denser, and the customers get more strategic, the engineering pressure rises with them. And one of the biggest reasons is cooling. This is where the story gets real. The Gulf has major advantages in capital, geography, and energy partnerships, but it also has extreme heat. That means cooling is not a side issue. It is the mission. Data Center Dynamics reported that the UAE Ministry of Energy and Infrastructure, Kazna, Agility, and FIDRA launched an AI efficiency pilot across selected COSNA campuses to optimize power, cooling, and workload management. Phaidra said its system has reduced cooling energy use by up to 40% in other settings, and the pilot is specifically aimed at improving reliability in the high-temperature environments common in the Middle East. That single update tells you everything about the real pressure on engineers, because when AI demand explodes, cooling becomes a battlefield. If you cannot cool the GPUs, you cannot use the GPUs. If you cannot use the GPUs efficiently, your economics break. If your economics break, your giant AI campus becomes an expensive monument instead of a working machine. So, the engineers inside these facilities are not just managing infrastructure, they are protecting the financial logic of the entire AI boom. And this pressure is not only technical, it is also human. The World Economic Forum noted that fields such as AI, data science, and cybersecurity are facing surging demand while struggling to find qualified candidates. It also highlighted that workers in GCC countries recognize specialized skill shortages, with the share of workers saying their country lacks people with specialized skills ranging from 45% in the UAE to 75% in Kuwait. That is important because AI data centers do not only need software engineers, they need electrical engineers, cooling experts, fiber planners, cybersecurity specialists, commissioning teams, reliability managers, and cloud operations talent, all at the same time. The Middle East Institute put it even more bluntly. Its report on the GCC AI stack said the region's goal is to become a critical and trusted AI node. But to do that, it still needs access to chips, expansion of data center infrastructure, and rapid development of indigenous technical talent. The report argues that the GCC could account for 5% to 10% of new global AI-optimized GPU deployments over the next decade if it continues securing chips, energy, and coordinated infrastructure. But it also says the region must build talent through labs, education, and broader talent pooling. So when we talk about pressure on AI engineers, we are talking about several layers of pressure happening at once. First, there is time pressure. These projects are being announced at geopolitical speed. Governments want results fast. Tech companies want capacity fast. Investors want proof fast. That means engineering teams are being asked to move from concept to deployment on highly compressed timelines. Second, there is thermal pressure. AI hardware is brutally power dense, and that means the cooling problem gets harder and more expensive. McKinsey says demand for AI-ready data center capacity is expected to rise at an average annual rate of 33% through 2030 in its mid-range scenario, and that the industry is facing supply constraints in power, electrical infrastructure, and labor. McKinsey also notes that traditional air cooling is becoming insufficient as rack densities rise, making the shift toward more advanced cooling systems increasingly necessary. Third, there is reliability pressure. A normal social media outage is embarrassing. An outage affecting sovereign AI, government workloads, or strategic enterprise systems is something else entirely. Once a region positions itself as a secure AI hub, engineers are no longer just maintaining uptime, they are defending national credibility. Fourth, there is compliance pressure. The more strategic these AI deployments become, the more every infrastructure decision becomes political. G42's chip export approval was explicitly framed around regulated deployment and trusted infrastructure. That means engineering is not only about performance, it is also about proving trust, auditability, control, and alignment with export rules. And fifth, there is geopolitical pressure, reported in early March that escalating tensions in the region were putting fresh attention on big tech's AI investments in the Middle East. In that same report, the scale of major regional commitments stood out. Microsoft said it plans $15.2 billion in UAE investment over 2023 to 2029, tied to its AI partnership with G42. AWS said it will invest more than $5.3 billion to build a new Saudi Arabia region by 2026. Google Cloud and Saudi Arabia's PIF said they will invest $10 billion to build and operate a global AI hub in the kingdom. Oracle said it will invest $1.5 billion to expand Saudi cloud infrastructure. Let that sink in. We are not talking about one company making one bet. We are watching an entire regional stack form in real time. AWS has said it plans to launch an infrastructure region in Saudi Arabia in 2026 with a $5.3 billion investment. Microsoft's Saudi Arabia East Cloud region is now reported for Q4 2026, with 3 availability zones in the Eastern Province. These are not abstract ambitions anymore. These are launch windows. And once launch windows are public, engineering teams inherit the countdown clock. That is why this story matters so much to US viewers, because AI is often described like software, but increasingly it behaves like heavy industry. It depends on construction, transmission, cooling, water strategy, grid coordination, specialized labor, and chip diplomacy. And the Middle East is now pushing hard to become one of the world's main places where that industrial side of AI gets built. So if you are an American watching this, here is the bottom line. What happens in Abu Dhabi, Riyadh, Jeddah, and across Gulf infrastructure networks will shape the future cost, speed, and geography of AI. It could influence where models are trained, where inference gets cheaper, where cloud services expand, and which political alliances shape access to next-generation compute. The Middle East is not just consuming AI anymore. It is trying to host the machinery behind it. And inside that machinery, the pressure on engineers is only increasing, because they are the people standing between the promise and the reality. They are the ones trying to turn chip approvals into running systems. They are the ones trying to turn billion-dollar announcements into stable throughput. They are the ones trying to make AI infrastructure work in a climate where heat is relentless, demand is rising, and expectations are global. They are the ones expected to make the world believe that the Middle East can become a trusted AI compute hub without blinking under pressure. And that may be the most important hidden AI story of the moment. So yes, America may be searching Sora today, but the deeper AI story is not only what AI can generate on your screen, it is who is building the power behind the screen. It is who can secure the chips. It is who can cool the clusters. It is who can keep the systems alive. And right now, one of the most important answers to that question is being written inside the AI data centers of the Middle East.